This lesson introduces graphing sequences. We looked at sequences last time. Sometimes it's convenient to represent the sequence with a graph. So if you consider this first sequence, 3, 5, 7, 9, 11, the way we translate that into a graph is we start here at the origin, and the first term is 3. So we go up 1, 2, 3, and we put a dot here. Okay, the next term of the sequence is 5, so I go over, and then I go up 1, 2, 3, 4, 5. And then the next term, so I move over 1 for the next term, is 7. That would be up here. And then the next term is 9. And the next term is 11, which doesn't even fit on my graph. You may wonder, why do we start here on the y-axis? Sometimes we could start somewhere else, but for convenience, we essentially consider this first term to be term 0. This is term 1, term 2, term 3, and term 4. So the ordered pairs that I'm graphing are 0, 3. That's this first one I graphed. 0, 3. That's right there. And then the next term, which we're calling term 1, is 5, and so on. It may seem odd that we start with 0, but we'll look at an example in class tomorrow that will hopefully show you why that is sometimes convenient and logical. All right, now I'm going to graph in red this other sequence. So it starts at 8, so I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. And then from 8, the next term is 2. So that's next term. So I move over 1, and now it's up 2. The next term is negative 4. 1, 2, 3, 4. And the next term, 5, 6, 7, 8, 9, and 10. And then you see I've run out of space on my graph. And that's basically how you graph a sequence. All right. Sometimes the sequence might be given not as a list, but as a recursive description. So this one, let's use blue. It says start at negative 5. Well, I always start along the y-axis. 1, 2, 3, 4, 5. So there's my starting term, and then I keep adding 4. So the next term is going to be 1, 2, 3, 4 more. And the next term is going to be 4 more than that. 1, 2, 3, 4. And the pattern continues. Over 1 for the next term, and then 1, 2, 3, 4. And it looks like that's all I can fit on this graph. Okay, you also need to be able to go in the reverse direction. So you'll see here a sequence in green. If I were going to list the terms of that sequence, well, the first one, the first dot, is at negative 2. The next one, positive 1. The next one, 1, 2, 3, 4. And then the next one, well, this was 4, so 5, 6, 7. 8, 9, 10, and so on. Or you could define that recursively by saying start at negative 2, and then what is our rule? We are repeatedly adding, let's see, 1, 2, 3, 1, 2, 3, and we repeatedly add 3. Okay, let's look at this other one in red. Alright, it looks like the first term is 1, 2, 3, 4, 5, 6. And then the next one is 1, 2, 3, 4 and a half, or 4.5. And then the next one is 1, 2, 3. And the next one is 1 and a half. And the next one is 0, and the next one is negative 1 and a half, and so on, dot, dot, dot. So if we were going to give a recursive definition or recursive description, I'd say start at 6 and then repeatedly or recursively subtract, well, from here we're going down 1.5. So subtract 1.5. And there you have a list of the first several terms as well as a recursive description. For homework number 13, go ahead and graph these three sequences. The first two are just given as a list. The third one is given as a recursive definition. Please put them on separate graphs so that they're easier to look at when I review them. And then lastly, go the opposite direction. Here's a picture of a sequence. You give me a recursive description of that sequence. Okay, see you tomorrow.